Okay, so yesterday we did solving systems of equations by graphing, substitution, and inequalities. Now we're going to do solving systems of inequalities by graphing. And so there's three things that you need to be able to do in order for this. First, you're going to graph both or all of the equations. Don't forget that some of them will be dotted, some of them will be solid according to the line. Then you'll shade for both or all of the lines above or below. And then your solution set is actually the overlap. So it has to be where both of them are shaded. So these are all already in y equals mx plus b form. We're going to graph both of these equations and then shade, and then we'll find the overlap. Okay, since they were already in beginner set form, I went ahead and graphed, and you might have to pause to do this, but I went ahead and graphed this one in red. This is started at -3, and then a rise of 2 and a run of 1. That's in purple. And then in red, I did the less than -x plus 2, so went up 2. And then this, remember, should be dashed because it's just less than. So I graph both of my lines, and then I want greater than my purple. So this is everything above it, all up in here. And I want everything less than for the red. And so that would be everything down here. Well, then your actual answer, so the solution set for these inequalities is the overlap. So that would be all of this part, the green part on my screen. All of this is the solution. And so really the easiest way to do this is to take 2 different color pencils. I have some in my classroom you can use, and shade the 2 different places, and then the overlap is the answer, and you don't have to mark that separately. I can see that the overlap's the answer. You will need to use a straight edge probably to be pretty precise. You don't have to use a ruler. You can just use the edge of a paper. That'll help it be neat with your slopes so that you don't have to plot every single point. And so this is the overlap. So any point I pick in here, and you can test it, and I recommend you do that. Any point I pick in here, any of these, or even on this line, because that's part of my solution set, not up here. Here it's not because it's not included. But any of these points, I can plug into x and y, and I'll get the same thing on both. So it'll work. I'll get the same thing on left and right here, and the same thing left and right here, and that will work. So the solution is this whole range. So how many solutions are there? Well, it's not everything, but there are infinitely many solutions. So I want you to pause and work this, check your progress, and then start it back and check your solution with me. So here's my first one. I just wanted you to see it before I lay my second one on top of it. Remember, you don't have to shade everything precisely, but you will need to extend your lines long enough and shade far enough out that you can see where it overlaps. Here, if I would have just done a little red arrow here, I wouldn't have known, what part this covered. So you'll probably need to extend your lines pretty much through the whole page. So now I graphed my second line, and it's dotted. And so now I am going to shade greater than that. And so that'll be everything up here. And so now you can see my overlap. It's this green part. And again, I'll highlight it for you. It's this part, and then it would, of course, keep going. So this keeps going. So it's all of that. And it is included on that line, just not this one. So all of that would be my solution set. Remember, there's some graph paper out there if you want graph paper, the little ones or the big ones. You might want to use highlighters or markers if that's easier, but color pencils are fine, and you can use anything that you see in my classroom. So now we're going to do another one, and they're already solved for y equals mx plus b as well. So I want you to graph both of these equations and shade and see what happens. Okay, so notice I color code mine. Please do that somehow. And you don't have to have 2 colors. You can draw one line in a color pencil and shade in that color. But do color code them you'll do this on your quizzes and on your tests and homework. You can tell by looking at these have the same slopes, so they're parallel lines, which means nothing. I mean, they could still have a solution set. When we do this, we have everything up here and everything down here. These are never going to overlap. So what does this mean for the solution? Well, there's no solution because the yellow is always going to work for the top equation and the blue is always going to work for the bottom. But there is nothing that is going to work for both of them. So while there's solutions to each individual equation, there's no solution to the system. So here there's no solution or no solution set. Okay, so now we're going to find the coordinates of the vertices. And so what this is going to be is like here, we want to know, okay, well, what is the vertice, the coordinates of the corners of this? So it's going to be the intersection points of the line, or up here. So like that, we're looking for this point. So we're looking for the intersection of the two lines. Now, when we're doing two lines, that's not hard to find. And that's what we did when we did the systems of equations, right? We were solving for their intersection, which is their solution. So that's part of what we do for a inequality. Now, that's not the only answer, but that helps us determine the answer. But we just graphed these and that was fine. Now, this gets a little bit more confusing with 3. And so for 3, we're going to find the intersection points and then go from there. But there's 3 equations. So you have the intersection point of those two, and those two. There's going to be 3 intersection points. So first, we're going to need to solve 3 sets of systems of equations. So this is a little bit longer problem, but fortunately it helps you practice everything that you've already worked on. So a lot of times it's helpful if you'll number them just so you know what you're talking about. So let's find the intersection of equation 1 and 2. And of course you have to show me work. You don't have to show me tons of work, but you will have to show me enough that I've seen what you did with all 3 equations. So I'm going to solve these 2 first. There's several ways you can solve it. We are going to solve a system of equations. Sorry, I should have had equal signs. And then we'll worry about the shading later. So equal signs, I'm going to do elimination. So this is a good review. Okay, so I get my x equals 1. It doesn't matter where I plug back into. I'm going to plug into the second equation here. So my first intersection point for equation 1 and 2, the vertex C would be 1, 3. So now let's do equation 2 and 3. I'm sorry, I know it's kind of loud. You might have to turn up your volume so that you can hear me. And again, we're doing the equation. Okay, so I'm going to, and this would be an easy substitution one. I'm going to multiply all of this by a negative and then do elimination. So, and hopefully I'll do this correctly. I get negative 3y equals 0. Okay, so that's okay. My variable hasn't canceled. This is fine. And so I get y equals 0. And then you can plug back into either one. I'm going to plug into the top. I get x plus 0 equals 4. So x equals 4. And this is 4. So there's my second vertex. So like I said, I know this is kind of a long problem, but it's a really good review. And really, it's not as long as some other stuff you've done. So now I'm going to do equation 1 and 3. And again, this is a pretty easy substitution one, but I told you I'm a huge fan of elimination. So I think I'm just gonna, I see this negative here. I think I'm just gonna multiply everything by 4, actually. Now there's tons of different ways to do that. I get 8x plus x, 9x, that cancels. Negative 4 and 4, I get 0, so again, x is 0. I'm gonna plug into the bottom equation. Now we get 0 plus 4y equals 5 and y. So my third vertex here is 0. Okay, so now that I have those, we're going to plot these points, and we need these inverted. Alright, I'm actually not going to plot the points, I'm going to plot the points. We need these vertices because we need the exact intersection. Right, we want to be really precise, so we need the exact intersection. So I am going to convert these over, and I am dividing the y equals, and I'm dividing by a negative So I'm going to start at 1 and then rise to run 1. And I don't know, maybe it's just me, but this graph paper looks a little weird to me. It's a little bit off. Sorry about that. Okay, and I'm not going to shade yet. Let's do x plus y, so that's y less than or equal to 4 minus x. So I'm going to start at 4 and go negative x, so down 1, 1. And like I said, I might need to extend those lines fully. And then lastly, to solve for y, divide by 4, and we get 1 minus 1/4 x. So I'm going to start at 1, where I already have 1, and then I'm going to go down 1 and run 4. Okay, so I have a lot going on in this little bitty picture. Okay, so let's check our vertices now. So I have 1, 3, and if you look for 3, okay, that's where those two intersect. I have 4, 0, that's where those two intersect, and I have 0, 1. So, did you have to do this? No, these all ended up on integers, and so as long as you were really neat, you could do that. But this is very helpful, and sometimes I will require it of you. So if I say find the vertices, I expect to see that algebraic work. Okay, you need to be able to do it both ways, but we still haven't answered that because we still have to find our solution. So on my purple one, I wanted everything less than that, so that's going to be everything here. On my orange, actually let's go green with green. I wanted everything greater than green. And then I wanted everything less than here. And so no surprise, that's really ugly, but no surprise. The overlap is, yeah, the overlap is in this little triangle. Will it always be in that triangle? No. And all of these are or equal to, so it's going to include those lines. So it is everything from those 3 vertices. And I know your node graph is really small. You make your graphs bigger, like if you use the graph paper that's a little bit bigger that we have, then that'll be a lot clearer. So I want you to pause and find the vertices. I want you to graph them and find the vertices, solve it, show all that work, and then check back, okay? So again, I know it's a lot of work, but you don't have many. I solved for my 3 vertices. And again, you can see pretty clear on it now. I counted by 2s on my graphs. And then I'm not going to shade everywhere. I'm just going to look. I need less than the blue line, less than the pink, and then greater than the purple. So again, it's going to fall into this region, and it is equal to, so I'm going to make sure my lines are highlighted because it can be anywhere there too. We're going to sub these notes there, and so now you can just sum.